The following question taken from a past paper. The question states that you have the stoichiometry of a catalyzed reaction is shown by the equation below. So there's a reaction given where P, which is a gas, and Q is also a gas. They're reacting to produce R, which is a gas, and S, which is in liquid state. And there's a reversible reaction happening. And the question states that two experiments were carried out in which the rate of production of R was measured. The results are shown in the diagram below. So this is the amount of R that is being produced. In the first experiment, R is being produced. Eventually, the amount of R becomes constant. And this constant concentration, this part over here probably indicates that the reaction has achieved an equilibrium because the amount of R that is being produced. So this probably states that either the reaction is complete or the amount of R has become constant because the amount of R that is being produced, it's the same amount of R is getting consumed again. So the amount of R becomes constant indicates that the rate of forward reaction, the rate of backward reaction are equal. So in experiment 1, equilibrium is reached. And then you have another experiment where the amount of R with respect to time is being produced at a slower rate. So this reaction is slower, the curve is less steep. So it's a slow reaction and it doesn't reach equilibrium. We don't know, it might reach an equilibrium at some point, but the amount of R is constantly increasing, which means that the forward reaction is happening at a faster rate compared to the backward reaction. Now we have three options with us. Which changes in the conditions might explain the results below? So what changes in the conditions in experiment 1 were done to get the results for experiment 2? So the first is a lower pressure was used in experiment 2. And this looks correct because if you use a lower pressure, the reaction would be slower. You're going to get a slower reaction, which is true in experiment 2. You have a slow reaction. Then you have the second option is a different catalyst was used in experiment 2. Again, that would indicate that the reaction might be slow. So again, using a different catalyst would probably slow down the reaction. So this is possible. A different catalyst in experiment 2 might have slowed down the reaction. And option 3 is that product S was continuously removed from the reaction vessel in experiment 2. So if you continuously remove product S, and remember we're talking about the amount of R that's being produced. So if you constantly remove product S, the rate of forward reaction, there would be no change in the rate of forward reaction because the rate of the forward reaction depends on the collisions that are occurring between P and Q. So if you increase the collision or effectiveness of collisions that are occurring between P and Q, then the amount of R that is produced per unit time, that would increase or that would decrease. S would have no effect on the rate of forward reaction or the amount of R that is being produced. So whether there's more S or there's less S, the amount of R that's being produced per unit time would have no effect with respect to S. So I don't think that this option 3 is correct. And even if S is being removed, the equilibrium would shift in the forward direction, so more R would be produced. We are looking for reasons why the amount of R or the rate of production of R has slowed down. So this option 3 seems to be incorrect. So if only 1 and 2 are correct, the correct option according to the marking key is going to be option B. Only statements 1 and 2 are correct.